Hello everyone, welcome to this video. This is now the part 3 of the series where we are talking about how to build your own simulated two-wheeled differential drive robot in Gazebo, and then carry out the autonomous navigation, all those things we want to see. So in the previous video we saw how we can make our robot move. So in the first video we just build the mechanical parts of the robot like chassis, wheels, giving attributes, all those things we do. In the second video we learn how to control the robot from the keyboard or publishing data to their command velocity. That means how do you make the robot move. We saw that. In this video we'll see how we add various sensors to the robot, for example camera and laser sensor, because a robot needs sensor to see the environment, right? It should be able to see the scene around it, or it should be able to know where the obstacles are. That's why we want to add sensors. So for this module you can directly download the source code from GitHub repository by using the following command, or you can build yourself by following the instruction that I describe now in this session. So the basic idea is that you download the sensor base branch of this Git repository within the Catkin workspace src folder, and then you run the Catkin make. So then you should be able to build the whole thing without any error. And after that you should do the standard process of updating the ROS tree by running this command source devel /setup.bash. Alright, so in order to add sensor to the robot, we'll first talk about how do we add camera, and then probably we'll talk about other sensors. So let's add a camera sensor to the robot. Okay, for this we'll have to provide we'll have to make these changes. The first one is to provide camera related description, link, joint information in the main URDF file, which is called skboard.zacro. Then we'll need to provide suitable Gazebo plugin into skboard Gazebo. Remember that we need these plugins to activate a particular sensor or actuator. For differential drive robot we included some ROS control Gazebo plugins. Similarly here for activating camera we need some plugins which we'll put into the skboard.gazebo file. Then we'll put some objects in the our world environment so that the robot can see some objects. If you remember, our original world is empty, it doesn't have anything to see, so we'll include some objects in our environment and in the skboard.world environment so that we can see some objects through our camera. And finally we will relaunch the world file using this command, which is our standard ROS launch command for loading this world environment. And then we'll use image view tool of ROS to view the scene as seen by the robot. Okay, and then we can use the rotate tool of GUI to face the robot towards objects, and then run this image view tool to see the its environment. All right, so if we see the changes that we need to do, for example in skboard.zacro we add one joint and one link. Joint tells you the connection between the two links. So for example it says the camera based joint is connected to the parent link called chassis, and the child link is camera, which is defined below. And as always, it has these attributes called collision, visual, and inertial. We know that collision tags provides its ability and is used by collision detection engine, so that you can detect collision with it. That means it's a physical object. Visual tags are used to give visual attributes, color, all those things. And inertial tags are used by the physics engine. Alright, so we know this one. So this has to be added to the original file. So that is why it shows a rad robot tag. That means it should be within this robot tag in the Zacro file. In the Gazebo file, we use a Gazebo plugin for camera, and it requires this camera controller, right? So the first part, Gazebo reference, provides the color and frame rate and all those things, the width and height of the frame and the format, all those things are provided. While in the lower part, which is the camera controller, it uses the lib gazebo_raws.camera.so library to activate that one. All right, and it is important to point it to the right node, which will be used for accessing the camera. All right, it is available. This is a topic that we'll use to access the data from camera. And in the escape.world, we include two pre-existing models called cabinet and postbox. So you can see it's easy to include the models. So first of all, you give the URI tag and choose the model and decide its pose, right, position and orientation within include. And the static property tells that it is a static, it is not going to move. All right, so it is for example, all other models are available at this link. You can see other models, you can choose any one of them. For example, many there, cabinet is there, bus is there, cafe is there. A lot of models are available with Gazebo, which you can include into your world environment. Okay, so once we make these changes and run the launch the world file, then you should be able to see it. So let's see how it works. So we will not write these files, rather we'll just see these files and verify that contents are as we explained just now. So we go to the 3, this is our workspace, and if we type raw cd escape description, and then we go to URD file folder, and let's check the first one. We'll check the file escape.zacro. So as you can see, we already have chassis, caster wheels, we have the left and right wheel, and this camera part is commented, so we'll just uncomment this part. Okay, with the laser scanner we still leave it commented. Probably we'll talk about later. For the time being, we add a camera link, and there should be a joint, corresponding joint for this. Yeah, the first one is a joint, and then second part is a link camera, and this is a joint information. Okay, so it's good. Now let's see gbim escape.gazebo. It has the chassis and other information. These two plugins is required for making the robot move. All right, So this is a Gazebo ROS control, and this is a differential drive controller. And for camera, we uncomment this part. As explained before, the first part adds the attributes such as the color and the width and height of the frame, format, while the lower one, the plugin, activates its function, and it is available at a topic /skboard/camera. Alright, so we'll leave the laser part commented out. So this is also done. And if we now go to ROS CD, skboard Gazebo, and CD worlds, and let's see gbeam skboard.world. So this part is commented out. We'll uncomment it. So we include two models. One is a cabinet and one is a post box, and we specify their position here. Okay. So after doing this, yes, so now what we'll do is go back to our main folder, then we run ROS launch skboard Gazebo. Let's see gbeam. We'll also check the skboard world. Say ROS CD skboard Gazebo. We can directly use ROS edit as well. Skboard. You remember we are using skboard_world2.launch. So if you see this file, so it uses the skboard_gazebo worlds and skboard.world. So this is fine, and we just added two models to the skboard.world, so it's all right, and everything else is already there, so we don't have to do anything here. All right, so now we do ROS launch skboard Gazebo skboard world2.launch. So as you can see, there is a camera on the front side of the robot. Its position, you can change by changing the parameters associated with the link position. So you can see that camera is here. Now we will cd now we'll run ROS run. We'll run the image view tool, which is given by this command, ROS run image view image. We specify the topic here, skboard camera 1, camera 1 image row. Let's check if this topic is available. So if I do ROS topic list, you see you have the lot of topics are available under skboard camera, and the one we'll be seeing is skboard camera 1 image raw. So that's what we are doing here. ROS run image view, yeah, image view, image skateboard camera 1 image raw. ROS run image view image fine. ROS run image view. Do I need to give another command? Image view. No. Skateboard camera 1 image raw. Okay, so there is a slight. Now it is already load. Image view has to be mentioned twice, so okay, fine. So we keep it here on the top. See, you can see that you can see the post box here in the view. So if I now rotate, you see the view is changing as we're rotating the robot, and then you can see the cabinet. And if we move the robot in the forward direction, so I'll just rotate it a little bit more, and then move it forward. So in any case, you can see that camera is working. So if I rotate it now, oh sorry, along the Z axis, you can see the post box, the position is moving. All right, so so our camera is working. All right. Now you can, if you are launching the RVs, so hopefully RVs will work. So ROS launch skateboard description skateboard rpg.launch. If we do this, first we'll have to add the robot. Okay, and change the map to SK Odom, and then you add the camera. And change the topic image raw. So as you can see the view here. All right. Alright, we can see the camera feed in the view itself. Now if you run RQT graph, just to show the relationship, if I run RQT graph, So you can see that this escape camera has these informations, all right, and this is being subscribed to by Gazebo, and it's also used by Arvis. So the data is being used by both Gazebo and Arvis, all right. And if you just want to see ROS on view frames, what is the command for that? TF view frames. Let's run TF view frames. If you run it, this shows the physical relationship between different parts of the robot. Events frames.pdf. So what we can see now, camera is connected to the chassis, and its position is published at this topic escape order. All right. So this is a static connection which is fixed with respect to the chassis. All right. So we covered this part. So now what we'll do is that we will add a laser sensor. It is similar. You just have to add a link called HOQ. You can give any name, and its parent link is chassis while the child is the HOQ link, and then we activate the corresponding plugin in the Gazebo file, and you need to have this HOQ DAE file, which is generally provided by the manufacturers or the one who builds the solid model and all those things. So that file needs to be there, and it is included in the repository. And if you want to use some other sensor, there is a link here. It is explained how we can use various other sensors that are available on this site. So it tells you camera. So the most of the content is taken from here. Okay, multiple cameras, then depth camera, Kinect you can add, GPU laser, and all these things are there. You can see force sensor, IMU data. All these sensors can be included into your robot. Alright, so if you see the content, as we explained earlier, it's not different. In escape Zacro, you add a joint name and the corresponding link for the laser sensor. And in escape Gazebo, include the Gazebo reference, that means its physical attributes as well as it's a plugin, leave Gazebo ROS laser.so. It is important that you use the right library. For example, if you don't have GPU on your system, as is my case, then you use the standard leave Gazebo _ ROS and laser. But if you have a GPU, then you should use GPU version of this one, and change this type, sensor type from ray to GPU ray. This is explained here. So it is important that you choose the right library here, otherwise it won't work. And now if I run these two commands, that means I launch the SK World and then launch the RVGS, should be able to see the laser scanner. So and just to verify, what we'll do, we'll close the previous windows of RVs and Gazebo. Yeah, Gazebo is already closed, so no problem. So we'll close this. Okay, now if we just see ROS add, ROS add is a good tool to edit the files directly without writing multiple commands, one for changing the directory, then finding the file, and then viewing it. So you can directly say, for example, I want to say ROS add skbot description. If I say skbot zacro, I am able to directly access it. So this is the power of using ROS add, and I have already used gvim as my editor, so you can do that as well. So if I do this, you can see that we have the chassis, caster wheel, left and right wheel, then we have a camera. Now we'll just uncomment this laser part. Okay, this is the joint, and this is the link for this one. So as you can see, the laser is connected to the chassis, which is the parent link, and the child is the HOQ, which is defined below. Okay, so this is all right. Now we see ROS add skbot description skbot.gazebo. We can directly access from here without having to go into that particular folder and using another editor to open it. So in that way, it is a pretty useful tool, the ROS add. So we have this differential drive controller, we have this camera controllers. Now we'll just uncomment this part. The point to note is that it is now topic name is skbot laser scan that we'll use to access the data stream from the sensors. Okay, so there are various parameters are there which I don't recommend changing it. Only thing you should remember is array. If you do not have GPU, then make it ray and use the right plugin there. But if you have a GPU, then you call it a GPU ray. That is the only change you'll have to make in case you have GPU. I don't have GPU, so I use just ray. So this is looks all right. Now we'll see. Did we see the Gazebo plugins for that? Yeah, so here it is ray, and the plugin is libgazebo ROS_laser. So if you're using GPU ray, then it should be ROS_GPU_laser, something of that sort. Okay, now this is done, so we should be able to launch Gazebo now. So if we see the ROS topic list, you should have this skbot_laser scan, and if you see this one, you can see the blue laser scan rays, and there are two obstacles here in the workspace which is visible here. It is possible to add more obstacles. For example, I click on a cube and place it here. I put a cylinder here, and you can see that the rays are getting blocked by these obstacles. All right, so and if I launch the RVs and choose map to be skbot autumn, then add robot model, then add laser scan. In the laser scan, you choose the right topic here, which is skbot laser scan, and you can make it the size to be 0.05 to make it thicker. So what is surprising is why doesn't it show any values. Am I missing something? Okay, we just have to rotate the robot around to see the obstacle because it is facing only in one direction. So as you can see, there are obstacles which are seen by these lines, red lines, which is thick. For example, if I put a sphere, let's say I zoom in and put a big sphere here, and I zoom in a little bit and probably scale this one a little bigger. So we make it bigger, and you see, I think that this is the sphere we included. So just to make sure this is the one. So what I do is that I move it closer, let's say here. Alright, so in the Harveys you see it has moved closer to the robot compared to others. So this is how the laser sensor works. Alright, so in this session we saw how to include a camera sensor as well as laser sensor to the robot. Now this the robot is more or less complete now. It has the actuator, that means you can move the wheels now, and you can add sensors so the robot can see the environment, it can move as well. So there is a way to give velocity command. Now we'll utilize this information for autonomous navigation in the next module. Thank you for your time.